All of the data we collected is all here and you can do whatever you want with it. Hello everyone, Pietro speaking and welcome to the Data Circle, your go-to place for useful data projects. In this video, we'll conduct a quick web scraping project on Facebook Marketplace, focusing specifically on vehicles. For that, we'll be using Python with libraries such as BeautifulSoup and Chromedriver. By the end of this video, you'll have the tools to gather data on average car model prices, mileage, and discover some great deals. Whether you're a car enthusiast or someone looking for data-driven insights, or even just looking for a project to add to your portfolio, this tutorial has something for you. So, without further ado, let's jump right in. I already have the comments for what I should be adding to each of the sections. Both this document and the final documents are going to be available in the Data Circle's GitHub, and I'll put a link to it in the description of this video. First thing we're going to do is importing the necessary libraries. From Splinter, we will be importing browser, which is going to allow us to interact with the Chrome browser. From BS4, or BeautifulSoup, and that's what's going to be parsing the HTML. Import RE for regular expressions. Import Pandas, which we're going to be using to conduct our analysis at the end of the project. Matplotlib and time. So Matplotlib for the plots and graphs that we're going to be doing, and time is going to be for the web scraping, and I'm going to be going into much more detail as we get to that section. Now we're going to be setting up Splinter as well as constructing a custom URL so you'll be able to filter the car listings. First thing we'll do is setting up the browser. We're going to be using Chrome, so browser Chrome. Second thing we're going to do is setting up the base URL. I would preferably do this with an incognito tab so you don't have to log in. When you go to Facebook Marketplace and search for your currency, you're going to see that this is the URL it gives you. I'm going to copy it to Jupyter so you guys can see it better. This is the URL it's going to give you. This is my city. You're going to see your city here, or even just a bunch of numbers that represent your current location. This URL is going to be our base URL, so we can store it in a variable called base URL. You also have to set up your search parameters, and that you can also get from the Facebook URL. So let's see here. Let me paste it on Jupyter so you guys can see it better. Over here you see a bunch of search criteria. You can see our base URL here. We can just remove that. And you see criteria such as minimum price, maximum price, days since listed, maximum mileage, max year, minimum mileage, minimum year, transmission type, and the type of vehicle you're looking for, which is going to be inside the query. So everything that comes after the interrogation mark is going to be your search criteria. And so what we're going to be doing now is creating variables to store those search criteria. So we start with minimum price, maximum price, day since listed, minimum mileage, minimum year, and maximum year. Now we're just going to set up this criteria, whatever you guys prefer. If you want to follow along, I'm going to choose a minimum price of $8,000, maximum price of 30K, days since listed 7, 50,000 miles minimum. Actually, in this tutorial, I'm going to be using kilometers because I'm in Canada. If you're in the US, you don't really have to specify if it's miles or kilometers. The page based on your location is already going to search in your home unit. To add maximum mileage here, let's do a cool 200K. Look for cars starting at the year 2000 up to 2020. For transmission, we're gonna choose automatic, and for this tutorial I'm going to be using a Honda Civic as an example. So we got all of our criteria set up. Now what we got to do is fill out our full URL. Basically we're going to store it inside a variable. Let's call it URL, and instead of the actual criteria here, you want to have the name of the variables that store such criteria. In order to do that, we can use a formatted string. So let's start copying and pasting our variables here. Don't forget to add the base URL at the beginning. So we already have our base URL here, because that's gonna compose our full URL once we start the Chromedriver. And there you go, you got the full URL. I just got a small mistake here, which I already fixed. This was maximum mileage, it was minimum mileage before. That's why you get the maximum mileage is not defined error here, just in case you are wondering. Now, visiting the URL, let's use the browser instance we created earlier and the method visit with our full URL. Now that we got that set up, let's run it block by block, all good. And you're gonna see that an automated Chrome window is gonna pop up on your screen. Once we run this line, which is the visit URL, you're gonna see that this window is gonna be directed to the full URL. And you can already see all of the results for Honda Civics within our search criteria. One thing you're gonna notice is that you don't get the results all at once. And in order to get that, to get more results loaded onto the screen, you need to scroll down. So the first step is gonna be figuring out how to get more results. So to do that, it's pretty simple. You just gotta have the browser scroll down as much as you want to get as many results as you would like. We're gonna be adding a piece of code that's gonna do just that. First thing you're gonna define is the number of times you want to scroll down. So we're gonna store that in a variable called scroll count. Let's leave it as 4 for now. And then the second thing you wanna set up is the scroll delay. So how much time you want there to be in between each scroll, because sometimes your browser or your computer or internet connection is not going to be as fast to load the whole page before you start the next scroll. So you got to add a delay there, or else it's going to return an error. I got it set to 2. And next thing you want to do is a loop to perform the scrolling, just a simple loop, and the range is gonna be the scroll count. We're gonna execute a JavaScript to scroll to the bottom of the page. For that script, let's use our browser and execute. So the 0 represents the horizontal scrolling, because you don't want any horizontal scrolling. Then document.body.scroll height, it tells it to scroll the full length of the web page. So let's say I'm here, it's gonna scroll all the way to the bottom, so it allows us to start loading more results. So you can see every time I reach the bottom here, it loads a couple more listings for us. So what about the scroll delay? And that's when it comes into play. So our scroll delay, we're gonna be using the time library here, sleep scroll delay. So the browser has the time to properly load the page before the next scroll. I forgot to add a column here in our for loop. So after you do that, you can just rerun the whole thing from the top. We got our page open and the scrolling is working. It scrolled 4 times. There's a small interval in between each scroll, just as we intended. Moving on, we're gonna be storing the HTML inside a variable from our browser. We're gathering the HTML. Now BeautifulSoup comes into play. That's how we're gonna be parsing the HTML, and then from that extracting all of the information we need. Let's create a BeautifulSoup object. Let's call it Market Soup, just because of Facebook Marketplace. And then from here, we're just gonna say which HTML we want it to parse and choose the HTML parser for that. There you go. And then you can look at the HTML, see if it was parsed correctly. You can just write the name of the BeautifulSoup object. So we can see here, that's our starting point from gathering all of the info we're gonna be using for this project. Since we already have the HTML stored, we can end the automated browsing session now. We're just gonna do browser.quit. That should close your Chrome window. Now we can start working with the data we got. First things first, we need to organize everything. So let's open Facebook here and I can show you some of the info we're gonna be distributing into lists. We got the vehicle price, and remember that we're getting everything from this page, which is what we scraped in the first place. So we got price, we got the name, we got the model and year, city, and we also got the mileage. So we want each piece of information to be inside a separate list. We're gonna be using BeautifulSoup to extract that information. First, we're gonna be gathering the titles for the listings. Now with the title, we can call our market soup, which is our BeautifulSoup object, and use the find all functionality. In order to figure out which element you're looking for, you need to go into the developer mode and figure out what's the name of the class or the div that you are looking for. Press F12 on Facebook Marketplace, select this option right here at the corner, which is going to allow you to click on the element you want. So I want the title. If I click on it, it takes me to the span class and then the name of the class. And with this right here, let's go back to our code. So first of all, we need to identify the elements, so span, and then the class that we just selected there, and paste everything in here. And you're gonna be doing that for pretty much every piece of information you want to extract. Once we get that information, we're not only getting the title. So in this case, as you can see here, you're not only getting what's here, but you're actually getting all of the CSS that comes with it. So all of this right here. And all we want is a text. So with the titles div, we're gonna create a titles list, and inside that list we're going to be doing a for loop, and that for loop is going to be going through each element that we got inside our titles div and stripping everything that's not pure text. This is how we're going to do it. A simple for loop here. We're going to get each title in the titles div and strip everything and just leave the text. We're going to be doing that for everything else as well. It's the same process. So you're just gonna go onto Marketplace, developer mode, use this option right here, and let's say you want the price, click on the price, you're gonna have a span class, just like we just did. You're gonna get the class here, copy and paste into our code. So let's call this one prices underscore div, and same thing as we did before, but we got a different class. There you go. And moving on, same thing for all of the rest. So let me just copy and paste for the sake of time. And there you go. Titles, prices, mileage, and URL. That's everything we're gonna be working with in this project. Now we can run it and let's look at some of the lists. So let's say we want to look at the titles list. We got all the titles. It seems to be all good. You might notice that we have some models here that don't fall within our criteria. For some reason, Facebook does that. It suggests different vehicles, similar vehicles. We're gonna be sorting that very soon. But for now, we can see it was successful. Now let's move on to our prices list, see if everything is okay. Yep. You can see here, we got our prices there. We got the CS in front of it. It's Canadian dollars. We're also going to be taking care of it in the next couple blocks of code. Then mileage. Okay, so this is where we run into a bit of an issue. As you can see here, we don't only have mileage, but there are also list items with the name of the city. And that happens because, as you can see here on Facebook, the mileage and the city are inside the same element. So we want to get mileage and city separately. And in order to do that, we're going to be using regular expressions, which are a great way to extract only the information you need from a certain piece of text. So first thing we're going to do is creating a pattern that represents the city and the province abbreviation. And if you guys have never used regular expressions before, I would suggest you go look into it, because it's a very powerful tool for data scraping. So pretty much you're determining a pattern that's representing a certain piece of text. So let me show you once again how that mileage div looks like, a list, sorry. So we can see here we always have the name of the city, comma, and the abbreviation for the province. This is what's gonna represent the name of the city. I'm not gonna get into too much detail, but you guys can look it up, regular expression patterns. There are even some websites, I can leave it in the description for you, where you can type in the type of text you want to extract, and it's gonna give you the exact pattern you need to look for that text. So this pattern here represents the city, and this one here, as you can see, A to Z, It's going to be the characters that are allowed, chew, so chew characters representing the abbreviation, and the comma here. Now, as you can see here, each vehicle has its own mileage, but it's not always like that. As you can see here, we got 2 consecutive cities, so no mileage in between them. So that means that this listing didn't have a mileage. And that's gonna be an issue when we clean this list, because it's gonna look for a pattern where there's a city and mileage, city and mileage, city and mileage. So what we're gonna do is just add some mileage for this listing, just so we can clean up the list later. If it seems a bit confusing now, just wait for it. It's gonna become a lot clearer. So let's create a new list for storing, let's say, our fixed list. So in this new list, we're gonna be adding all of the items from the old list. Now, this part might get a little confusing, so I'm gonna go a bit slower and try to explain it the best way I can. What we're trying to do here is eliminating those entries where we don't have a mileage in between locations. And our way of doing that is trying to identify if we have 2 entries inside that mileage list, 2 consecutive entries where you got the pattern that matches the location and no mileage in between them. And our way of doing that is iterating through our list, adding those items into a new list, which you can see here, the mileage list 2, and then comparing our current item to the previous item, see if the patterns are the same, so see if we have 2 consecutive cities. And then once we know that, we gotta add a mileage in between them. So we're just gonna add 0 miles, because in the future, we're gonna be transforming them into a data frame. And in that data frame, you need to have the same length for all of the lists. So each vehicle needs to have a piece of information from every list. And if you don't have a mileage, that list is going to be shorter than the other ones, and we're not going to be able to create our data frame. So let's start a if statement here. So if this if statement, so we're checking if our current entry from that list matches the same pattern as the previous one. And if it does, we're going to be inserting a mileage in between them. And we're doing that by checking if the list is at least 2 items long, because if you only have 1 item, there's no reason in comparing it. So that's why we have here the length of the adjusted list. And we're checking if the pattern of the current item we're going through matches the pattern of the previous item. So that's why we got the -2 here. If that happens, we need to add some mileage. And to do that, we're just gonna insert this in there. So let's say we're here where we don't have a mileage for a certain vehicle. We're iterating through the list. We get to this item. We see if there's a pattern match between the current item and the previous one. We found a match. Both of them are locations based on our regular expressions pattern. And we add this in between here. And that's what this piece of code is doing. Now we can run it. All right, we just forgot a column. To add a column right here. Let's see if our new mileage list doesn't contain consecutive CD entries. There you go. So this is the one we adjusted. Before there was nothing here, and now we got the 0K kilometers. Next thing we're gonna do is remove the location from the mileage list. We're gonna be using regular expressions once again. Let's create a pattern for the mileage. This one is for when it's in kilometers, and this one is for when it's in miles. Here in Canada, some cars might be listed with their mileage in actual miles, but most of the time it's kilometers. But we gotta account for that, because if it happens, we gotta be prepared. This is for the numbers, and then the letter K, and then either km for kilometers or miles. Once we have those patterns set up, we're gonna create a new list. This one's gonna store the clean mileage data with only the numbers. Once we have that, we can move on to iterating through our previous list the one we just got, the adjusted list, and then removing the locations and adding only the clean mileages to our new list. So let's iterate for item. So we're gonna do this first for kilometers. KM. And same as before, I'm just gonna copy and paste this one so we can save some time. So this is the pattern you're looking for. You can see it here, and you're looking for in the current item that you're iterating through. So this item right here. We'll do the same thing for when it's in miles. So let's create an if statement, just like we did previously when we're trying to find the location. So if there's a match with either one of them, then we're gonna clean that data. If we match the pattern for the mileage in kilometers, we're gonna be appending the actual mileage. We need to separate it from the K kilometers, then make it into an integer, and then multiply it by 1000. So that's what we're doing here. So we're transforming it to an integer, but we cannot transform the whole thing, or else it's not gonna work because we got the K kilometers here. So we gotta use the group and then 1. So it's only gonna get the first part. So the first part is gonna be the actual number. Now this is gonna add a number to our final list. And we can just do the same thing if for the case where it's in miles. So we wanna multiply it by 1600, which is the conversion from miles to kilometers, because I'm gonna be working only in kilometers from now on. Okay, we got a small error here. Let's check our mileage clean list and see if we only got what we want. You can see here, everything is good. Now, before we can proceed to converting our lists into a Pandas data frame, we first need to create a list of dictionaries. And in order to do that, we gotta first, once again, create an empty list. Let's call it vehicles list. And once again, we're going to be iterating through our lists so that we can create multiple dictionaries. Each dictionary is going to contain one vehicle, and each one's going to be one line in our Pandas data frame. We're going to do a bit of a different for loop. In this case, we need both the item and the actual index for that item. So we're going to do for item in enumerate. And we're going to use the titles list as a basis. It doesn't really matter which one you use here because all of them are the same length. So as I said, each car is going to be a dictionary. So we're going to create a cars underscore dict. And now we want to create a different field for each piece of data we need. We first need to split the title because as you can see here, both the year and the make and model of the vehicle are all inside the same element. We want to split that. We want to get the year into one field and the make and model into a different field. So we're gonna do a title split variable, which is gonna contain both the year and the make and model. And then each one of those are gonna be added into a different field. So let's start by the year. The year is going to be the first part of the title. That's why we're getting title split 0. And then I'm just converting it into an integer. Now we'll do pretty much the same thing for make and model. So this one's going to be make. This one's going to be the model. This is going to be title split 1 and this is going to be title split 2. And just like that, from one individual field, which had year, make, and model, we're dividing it into 3 different fields. Now for the price. So there's a catch there as well. So let's just do the cars dict price. And as we saw earlier, our prices list had the CS in front of it and also the comma. We don't want any of that. We want just the number. And our way of doing that is going to be once again through regular expressions. Also, I forgot, we don't need this to be an integer, of course, because it's just text. So now we're going to be using regular expressions, and we're going to be using sub to substitute all of that we don't want, so the CS and the comma, for an empty space. And we're getting it from the prices list. And here you can see why we needed to have the index, because, or else how is the code supposed to know which item are we talking about? We got the mileage, and the mileage, as we already cleaned it, it's gonna be the simplest of them all. And last but not least, we got the URL. And then once we have the dictionary with all of the data for a single vehicle, we can add that vehicle to the vehicles list we just created. All right, we seem to have everything into place here. Now let's look at our vehicles list. Seems like we got everything in place. And now it's finally time to convert our vehicles list into a Pandas data frame. Let's call it vehicles df. So vehicles df is gonna be pd.dataframe. Let's check it out. And there you go. We got our vehicles data frame. So every vehicle has everything we need. And now we're almost getting to the fun part. Before, we just need to do some cleaning. First thing we're gonna do, we're gonna be adding the facebook.com to the beginning of the URLs. As you can see here, it starts at marketplace. We want to have a full URL. So whenever we get one, we can just copy and paste it or just follow it through this website. We don't have to manually type it in. We're just gonna be adding, so we choose the URL field in the vehicles df data frame, and that's gonna be equals to what's already there. That's already there, plus https facebook.com. Once we do that, we can just run it, and then we can show our vehicles df once again. And as you can see, now we got the facebook.com in front of all of the URLs. Now another step into cleaning our data frame. We can see it here that we had some vehicles that do not correspond to our search. Some that are similar to what we're looking for, but some that are quite different. So as you can see here, we got a Dodge Grand, which is probably a Grand Caravan. We don't want that. That's not good for us. That's not good for our analysis. So let's just do something real quick. Create a new filtered underscore df. And that's only going to contain the Honda Civics that we were looking for based on the model we set up in the beginning. So as you can see here, the model needs to be the same as the variable model that we set up in the beginning. Now, why do we have lower here? That's because we might have some that start with capital and some that don't. So in that case, we want to be comparing apples to apples. That's why we put lower in both. So it's always going to compare lower to lower. One other thing to note is the .str here. That's to make sure that it's a string. Some vehicles might have numbers for a name, and that might not work. So that's why we're turning everything into strings. Let's run it. Seems like I forgot a bracket. And I did indeed forget a bracket. There you go. We're gonna be using single quotes here. Just some quick corrections. Very good. Let's check our filter df. So all we see are Honda Civics. We're good to go. Now that we're done with our cleaning, we can finally move on to doing some analysis. I'm just going to be doing a couple basic analysis here, and you guys feel free to let your imagination roam. My idea was getting some data related to price, average pricing by vehicle, as well as average mileage and number of listings. First, let's start with the average price by year. And to do that, we're going to be using the group by. We can call it yearly prices. So we're going to be using group by, so we're grouping by year, we're grouping price by year, and we're getting the mean. That's what we want. And then we can move on to plotting what we got. I'll be creating a bar chart. So PLT, that's where our matplotlib comes into place. So PLT.bar, and then we want yearly prices by index, which is going to be the actual year, by yearly prices values, which are the means that we just got. Now let's see how our bar chart turns out. So you can see there's a trend. Of course, older vehicles tend to cost less. We can still do a couple things in order to make our graph more presentable. We can increase our figure so it's not too cluttered. We can also add labels to it, so it's only gonna show in the end once we apply everything we want to apply to it. And then here we're gonna be making it a bit bigger, a bit wider, and here we're gonna be adding our labels and our title. Just for the size, we want to put it before, or else it's gonna create two different figures. And there you go. So we got average price by year, year, and price. And one more thing I'd like to add is adding the values to the top of the bars. This is just my personal preference. So it makes it a bit easier to read. If you guys would like to do the same, you can always pause the video and copy it. Or you can always go to the Data Circles GitHub and get the complete file from there. All right. The next thing I'd like to do is getting average mileage per year. So I'm just going to copy this because it's going to be very similar to what we just did. So, let's see what we got. You can see quite an interesting trend here. So here it's what we expect, right? So the newer vehicles have lower mileage, but since we set a threshold for our 200,000 kilometers, from here on, it's all over the place. One more thing we'd like to do here is filter out whenever the mileage is 0, because we know that's not the case, even because we added a couple zeros at the beginning there. It's very hard, especially like in the search criteria we set, which was up to 2020. We're not going to be seeing new unused vehicles there. So we know wherever it's 0 miles, it's not actually 0. So I'm just gonna be filtering it so we don't show vehicles with 0 miles. So filter underscore df is gonna be equals to filter underscore df. And once again, filter df. We're going for mileage, and we want it to be different than 0. Now we won't have any 0 mileage vehicles. Now that we got that out of the way, one more thing I'd like to do is get a availability chart, knowing how many listings are there for each model year. Let's do it here. So it's going to be very similar to this. Main thing is that now we don't need a mean, we actually need the size. So that's going to count how many. We don't need this because we just need the number of records for each year. And then we can just say yearly count. And we can always just copy and paste everything here. Number of listings. And the title is going to be number of listings by year. We don't need this. And we should be good to go. Let's check it out. All right, so we have the number of listings by year. One thing I forgot to put here, and then the last one as well. Oh, also we can see that the axis here, we got the years .5, .0. We don't really need that. We don't have this info. We don't know if the car was made in the exact middle of the year, so we don't really need that. Let's fix that real quick. I'm just gonna do an adaptive scale for the year axis, and we're gonna add it to all of the charts. So pretty much what this is doing is it's changing the x-axis, so the x ticks, to use the index from the yearly miles in this case, from the actual years that are contained within the data frame. There you go. Now you can see we don't have the 0.5s anymore, and you can do that for all of them. One more thing I'd like to do before we finish is get the best deals. So we're gonna be getting the URL for the cheapest Civic for a specific model year. So let's see. So I want to store that URL inside a variable. Let's call it cheapest Civic URL. We want to get the minimum price from the filter df. So that price must be equal to the minimum price of the data frame. So we can copy and paste this one and just write .min here. So we're gonna get the minimum, so the cheapest one. And what we want to extract from that would be the URL in all capitals. And we just want the first value. So we just do values 0. And that's it. So now we should have the cheapest Civic. Let's run it. And let's see what we got here. So this should be the cheapest vehicle around. Let's check it out. Yep, 1,500 bucks. That's pretty cheap. As you can see, since we scrolled quite a lot, we got a bit far from my area. You can see here this is in a different province, which is way more than 65 kilometers from Toronto, where I'm currently at. But this checks out. It's a very cheap car, and you can see why. Especially from this picture right here. Yeah, it's a rust bucket. Anyways, looks like a good deal. Now, one last thing you can do is saving all of the data inside the filter df as a CSV file. So then you can open it with Excel and create some more charts or graphs or whatever you want in there. You do that by stipulating the file path, CSV underscore file underscore path, and then create a raw string. That's very important because of the backslashes that might not work when you're working with Windows specifically. And then just input the file path that you want to save your CSV to. This is mine. And then all you gotta do is filtered . And now, just like that, I have all of my listings stored in a CSV file that I can just click to open with Excel. There you go. All of the data we collected is all here, and you can do whatever you want with it. That should do it. That's a wrap. So thanks for joining us at the Data Circle. In this video, we explored web scraping on Facebook Marketplace for vehicles using Python. And hopefully now you can analyze car prices, mileage data, and uncover some amazing deals in the process. Feel free to add this project to your portfolio, and if you enjoyed this video, please like, subscribe, and stay tuned for more exciting data projects in the future. Until next time, and happy scraping!